Hey there, ladies and gentlemen. What a seemingly difficult question, but that's not actually difficult at all to figure out once you kind of know a couple of things. I told you on the review on the first couple of pages there might be some kind of miscellaneous weird information that, frankly, you should know already because it's like really like fifth, sixth, seventh grade information. But you might need some time to actually take a second and recall. So if you have not done this yet, you better go stop this video right now. Go to YouTube, search properties of a parallelogram, especially about the diagonals and side lengths and angles, and do that before you look at this problem because you're going to be extremely confused if you don't do that first, okay? So that is my sincere advice. Stop this video right now if you don't know what's true about the diagonals of a parallelogram, about the angles of a parallelogram, and the sides of a parallelogram, and do it even faster if you don't know what it means to be a parallelogram, all right? So please, please, please do that and do it quick, all right? The other thing you should also do before you come back is review what it means to be the base angle theorem. We mentioned it in class, used it a few times, and frankly has not been a consistent feature of things we've done. And that's what's really going to help you out to give you some variety in how you can answer this question. Okay, ah, so we have to find the value of all these angles, and we should be prepared to kind of justify how we know some of these angles have the value they do. And I'm not going to necessarily write that all out, but I will kind of talk through my reasoning. But again, hint, hint, you're going to have to be able to kind of tell me how you know each of these angles are the value that they actually are. So let's get into it. So these numbers are not numbered sequentially, like I have to figure out one first, but in this case, I probably want to. So I'm going to go ahead and write in red that angle 1 is actually equal to 140 degrees. Now this is true because of vertical angles. They're at an intersection, they're in opposite spots, they share a vertice, therefore vertical angles are in play. That guy's 140 degrees. Now immediately, because that guy's 140 degrees, actually both these guys are, angle 2 has to be 40 degrees. That's linear pair posture. So angle 1 and angle 2 form a line together, and angle 1 is 140 degrees, and since they're supplementary, boom, angle 2's got to be 40 degrees. Now here's where it gets kind of bananas. And what I mean by bananas is now it seems like I might be a little stuck. Now I'm not stuck, and the reason I'm not stuck is because I took time to review the base angle theorem, and the base angle theorem states that if I'm in an isosceles triangle, which I happen to be because I know these sides are congruent, then I know that angle 3 and angle 4 have to be congruent. If I combine that with the triangle sum theorem, which states that all the angles within a triangle have to be congruent, and I do have a triangle here, I know that angle 3 and angle 4 have to be 140 degrees and congruent because, again, by base angles theorem, we're in an isosceles triangle, so it has to split up those angles equally. So this guy is equal to 70 degrees, and this guy is equal to 70 degrees. I'm going to jump order because I had kind of ironically kind of gone in order, and I'm going to go ahead and take care of angle 7 really fast. Angle 7 is interesting because since we do have a parallelogram, because of parallel lines, angle 7 is, excuse me, let me back up. Because we have parallel lines cut by a transversal, 1 and 7 are consecutive interior angles, and therefore supplementary, so that has to be 40 degrees as well. So now let's work the upper parts. We're not going to make the mistake by thinking angle 3 and angle 8 are vertical. They're actually not vertical, and the reason they're not vertical because angle 3 and angle 8 result of the intersection of not two lines, but actually three lines. This guy, this guy, and this guy. So 3 and 8 actually aren't vertical. So let's leave 8 alone for a little bit. But what I do want to look at is this. I have a parallelogram, and since I did what Mr. Collins asked and reviewed the properties of parallelogram, I can actually solve all these angles really, really fast because in a parallelogram, I know that opposite angles are congruent. So this guy's 140 degrees. And because I have all these parallel lines cut by transversals, I know that 140 and angle 6 have to be supplementary. So this guy is equal to 40 degrees. And since in a parallelogram they're opposites, angle 7 is 40 degrees as well. So that leaves us only angle 8, but angle 8 is hardly a problem because we have linear pairs for angle 8. And that means angle 8 and angle 7 have to add 180 degrees, making that 40 degrees. So again, go review that. So it seems to me to do this problem well, I have to know a lot of different competencies. I have to know about all these Pasch's theorems. In fact, some that I haven't reviewed in a while. But this problem is totally doable. Oh, look, another example. How about that? So again, we have all these parallel lines. We have some starting points. Um, so let's take some time to actually map this out. So I have 60 degrees here, and it seems like that should be enough to get me started. Okay, so the first thing I'm going to observe is that if I have 60 degrees here, I'm looking at some parallel lines, because I have the one mark here as well, cut by this transversal. So I know that angle 5 has to immediately equal, oh, not 50, back that up, 60 degrees. Okay. So that leads me to a lot of kind of interesting revelations. First of all, I have a vertical angle at 1, so that's got to equal 60 degrees. Okay. But also, I have another parallel line here, so this 60 has to equal angle 3 as well, so that's 60. Well, look at that. Okay. So now, what do we want to attack next? Well, I actually want to go to this inner triangle, because again, since I took Mr. Collins' advice and reviewed base angle theorem, I'm going to notice once again that I have an isosceles triangle. And since I have an isosceles triangle, I know angle 1 and angle 3 have to be congruent, so that's 60 degrees as well. And because of triangle sum theorem, 60 and 60 make 120. The entire triangle has to be 180. So angle 2 is going to be 60 degrees as well. Now, not nearly to scale, but hey, what can you do? I never said it had to be to scale. In fact, most of the things I give you are not on purpose. We can now attack angle 6 because angle 6 and angle 3 are vertical, making that 60 degrees. Man, look at all these 60 degrees. And 6 and 4 have to be congruent because of alternate interior angles, so that's 60 degrees again. So now we only have two more, and it seems to me like these might be the wackiest ones to find because they're kind of off by themselves. Now, this is not going to scare us because we're going to make a basic observation. I have a parallel line and a parallel line, and I have 8 and I have 1. And if I look at angle 8 and I look at angle 1, which is right there, I can observe that those are actually consecutive interior angles. That means they summed 180 degrees, which means that guy's 120. The exact reasoning I can repeat for this parallel line and this parallel line. Angle 3 and angle 7 are actually corresponding. So 3 and 7 have got to be congruent, hence being 60 degrees. So kind of wacky. You have to know quite a bit. Like you can't slack at all on any of your properties, but just an interesting way to combine a lot of different competencies together to get a bunch of angles. Okay, so definitely study these two. Definitely study these two again, and make sure you're able to use all these theorems really well. That's it for this part of the video. I think this is part 3. I'll see you in part 4.